Backstep Blockchain by George Krause, Blockchain Systems Private Limited. Technology, made in Singapore. Let's see how ideas become a game-changing technology. The original idea of chaining hashes is so simple yet so beautiful. As a result, blockchain has changed the world. The invention of the backstep blockchain can put the blockchain everywhere and make it really huge. And now we see how. Imagine your blockchain can create thousands of blocks in a blink of an eye. It pays for itself with the savings from your energy bill. It's so small that it fits into a chip in your smartphone. It can work with or without a network. Can hold all your personal records. Here is a traditional chain. Using Bitcoin blockchain as an example. The payload, together with the hash value from previous block and the nonce field, are hashed to form the hash value for the next block. Each block contains the hash of the previous block. This is blockchain. On the right it shows the principle of hashing. Here, the first byte of the payload is mixed with a fixed start value, and goes through a one-way function. The result is then mixed with the second byte of the payload, and again it goes through the one-way function. This process is repeated, until the last byte of the block. The result is the hash value of the block. Hashing is irreversible, you cannot reverse the process to recover the original input. In the Bitcoin blockchain, how do you trust the integrity and authenticity of the data? Well, for one, the hashing calculation can be made more difficult. This is called the proof of work. It is a simple trick, but will need lots computing power, and requires many nodes working together. We will see that it is difficult to attack. Next slide, we will show you how it is done. Shown here in this slide is a typical Bitcoin block. The probability of getting a bit in 0 is 50%. The probability of getting two adjacent bits in 0 is 25%. In the case of Bitcoin, there are 72 adjacent bits that needs to be 0, hence the probability is huge as you can see. The proof of work is done by incrementing the nonce value, and do the hashing until the correct 0 are achieved. The proof of work protection. If the hacker tries to modify the data in one block, see the diagram on the left. He will need to recalculate all the hashing in the remaining blocks to catch up with the original chain. In order to outrun the original chain, he will need to seize 51% of the machines on the network to help him work on the modified chain. Only then can he fool the rest of the machines that his chain is the correct chain. This is a lot of work. The consequences of proof of work. A typical hashing machine with 1 terahash per second consumes about 81 watts per second. To do the proof of work with one machine it will take roughly 149 years, or about 130,000 machines in 10 minutes. As you can see from the calculation, it takes about 106 megawatts to generate one block in 10 minutes. If we extrapolate it to an hour, it is about 636 megawatt per hour. Here is a chart to give you a better perspective on the energy consumed by Bitcoin per year. As you can see, Bitcoin consume more energy than countries like Hong Kong, Iraq, or Peru and very close to Singapore. Most of these energy are wasted in the proof of work. We need to fix this. We need to remove the proof of work. But, simply removing the proof of work could lose the essential security, and the chain can be faked. Luckily, we found a transplant. We removed the nonce field, and replaced it with the backstep value and backstep seal value. This is how the backstep blockchain got its name. We have a backstep generator, that calculates the backstep values from the future to the past. This is how we do it. The backstep value is generated from a secret value, and it goes through a one-way function. The backstep value is made available only when the next block is required. This slide shows the logical flow of the backstep values. As shown, the backstep values are calculated from the future, starting from a secret value, and to the past. The backstep values are generated by the backstep generator as shown. The backstep generator can run up to 20 million loop per second, using the one-way function in the field programmable gate arrays or FPGA chip. Here is the block diagram for the one-way function, using 2 AES 128 bits encryption to combine to have 256 bits output. The backstep generator speed calculation. For our entry-level product, assuming client requires 1 block per second and for the next 10 years, it will require about 315 million backstep values. At 2 million cycles per second, it will take roughly 2 minutes for the device to calculate from the initial secret value to the backstep value required by the first block. As you can see for the mid-range product, at 20 million cycles per second and assuming the client requires 5,000 blocks per second, it will take 43 hours to get to the first backstep value. Our backstep blockchain will be useless if it takes this long. In the next 2 slides, we will explain how we overcome this by adding checkpoints and multi-level caching to improve the speed. By introducing checkpoints, we have effectively reduced the time it takes to backstep to the first value from 28 hours to just 10 seconds. All that is required is a 32 MB non-volatile storage. Again, 10 seconds is still not fast enough. In the next slide we will show you how we use the multi-level caching, so that the backstep values are available instantly when a block is required. Dynamically allocating multi-level cache. As shown in this slide, there are 6 levels of caches. Level 1 stores 128 backstep values in the primary cache and in the secondary cache another 128 backstep values. Level 2 also has primary and secondary caches. It stores the starting backstep value for level 1 cache. That means, the first of the 128 backstep values in level 1 cache is stored in level 2 cache. The values in level 2 is fed into the one-way function which will then calculates the next 128 backstep values and fills up the level 1 caches. Same applies to next higher levels. Each level cache stores only the first starting backstep values of the next lower level cache, except for level 1 cache. This slide give a much more detail on the caching, how they are being filled as they goes up the levels. By using this caching strategy, we need only less than 16 KB of storage and yet is able to cache up to 50 million backstep values. Same applies to the backstep seal values, using the same caching strategy. A hacker could copy the original chain, and make modification to the payload and regenerates the remaining blocks. But he will not be able to generate the next new block, as he has no access to the backstep generator to generate the next backstep value. It can be verified that his block is fake, by simply asking him to generate the next new block with an empty payload. Can we trust the owner? Often fraud is committed by people within the organization. Since the owner has access to the backstep generator, the hardware, he can easily manipulate the records undetected. And to protect the owner from making modifications to the chain, we have added a seal value to the block. This seal value is the result of a cryptographic operation that includes another one-way function to prevent backward calculations to the running value. It will change whenever the hash of a previous block is changed. This slide shows the protection of the seal. The backstep seal value is XOR with the hash of previous block and goes through a one-way function. The result, seal value, is then stored in the block. The backstep seal value is not stored in the block like the backstep value, but rather, it is the result of a one-way function from the XOR operation. The hacker will not be able to reproduce the backstep seal value with his modified payload. Here is a slide to show you the effect of the seal. On the left is a normal chain, and on the right is a modified chain. The hacker will not be able to regenerate the next block, since he does not have the next backstep seal value. Here is a picture to compare the amount of hardware required for a Bitcoin mining, versus our backstep blockchain device. Common mistakes people hear from the internet. There are people who claim their blockchain is fastest, but they are counting transactions and not the number of blocks. This is a common trick some people use. In Bitcoin, there are 1000 transactions in a block. It uses the Merkle hash that places the root hash in the block. There are 9 layers in the Merkle hash covering 1024 transactions. The diagram below gives you an idea how Merkle hash works. We will provide the hardware, and also adapt the software, for building the blocks, chain verification, and chain synchronization. We will work with industry's players whom will provide the applications, the chain management and monitoring, etc., that is customized to their industry's needs. End of technology. Now, let's talk business opportunities. Blockchain need not be distributed. People accepted it, because nobody question it. Current blockchains are costly, directly or indirectly. Large network nodes are needed. Blockchain today is difficult to scale. They are for the large organizations or governments. Advantages of our backstep blockchain or BSB. It is reliable with 3 to 5 BSB devices in different locations with RAID systems. Small and medium companies will have access to our BSB. It is fast, capable of 20,000 blocks per second. It can be made into a chip in smartphones and you will have your personal BSB. It can be integrated to IoT devices, SCADA systems, and machineries. There are fantastic opportunities with our BSB. We can have BSB in autonomous vehicles, trains, delivery trucks, accounting systems. There are countless possibilities. The list will go on. We are looking to launch 2 initial products this year. One that is entry-level and the other mid-range. The entry-level product is capable of 1000 blocks per second, suitable for development purposes, and also for small enterprise. The mid-range product is capable of 5000 blocks per second, with state-of-the-art hardware anti-tampering device, redundant power inputs and self-erase in case of physical attacks. Here is a picture of the entry-level product. To the market. We will initially sell the product direct, and later via supply chain worldwide. Blockchain generators for partners for integration into their product, and also OEM customers like IBM, Apple, etc. Block licenses for different markets. Example, for smartphone users, charge 1 cent per block. Blockchain licenses for integration into chips for IoT devices, SCADA, machineries, etc. Please help make us it a success. We appreciate a Singapore partner, with money to finance the BSB business, and the right connections to key people.